To understand what Mars can truly reveal to us, we must look beyond the present-day challenges and instead rewind the clock, back to a time when Mars was a young, warm, and potentially wet world. At infinity beyond, we believe the ancient past of the red planet holds the deepest answers to one of humanity's oldest questions. Are we alone? Roughly 3.5 to 4 billion years ago, Mars likely had a thicker atmosphere, warmer surface conditions, and abundant liquid water. In fact, the Noachian period, named after the biblical figure Noah due to its association with water, was marked by heavy bombardment, volcanic activity, and active hydrological systems. Valley networks, delta fans, and sediment layers all point to a planet that once experienced rainfall, flowing rivers, and perhaps even global oceans. These aren't just geologic curiosities, they're potential habitats. On Earth, wherever there is liquid water, there is life. From the scalding vents of the deep ocean to the frigid lakes beneath Antarctica's ice, microbial life finds a way to adapt and endure. If Mars had similar environments, stable lakes, volcanic warmth, and a chemically active atmosphere, then the basic conditions for life as we know it may have existed. The question is, did it? That's why Mars missions have focused on ancient lake beds and sedimentary regions, places like Gale Crater, where Curiosity discovered clay minerals that form only in neutral pH water, and Jezero Crater, where Perseverance is now investigating a once lush river delta. These sites are not chosen at random. They represent the best chances of preserving biosignatures, chemical or morphological traces of past life, locked in rock for billions of years. In many ways, Mars is more ideal for this search than Earth. On our planet, tectonic activity, erosion, and biological processes recycle or destroy much of the rock record. Mars, by contrast, is geologically quiet. Its ancient surfaces have remained largely undisturbed, preserving a planetary time capsule from the earliest epochs of the solar system. Imagine finding a microfossil in Martian rock, a clear imprint of life that arose independently of Earth. Such a discovery would fundamentally reshape our understanding of biology, evolution, and the prevalence of life in the universe. It would mean that life is not a miracle, but a natural outcome when the right ingredients come together. Even if life never existed on Mars, studying why it didn't emerge, or why it failed to survive, offers invaluable insight. It allows us to test the boundaries of habitability and refine our criteria for searching on other worlds. What if life nearly took hold, but Mars lost its magnetic field too soon, or dried out too quickly? These scenarios would help explain not just the silence of Mars, but perhaps the silence of the stars as well. Subsurface exploration may hold the key. As the surface grew more hostile over time, any microbial life may have migrated underground, where geothermal heat, subsurface ice, and protected niches could have extended habitability by millions or even billions of years. Future missions equipped with drilling systems and biosensors may one day reach these hidden reservoirs. At infinity beyond, we view the ancient Martian world as a mirror of early Earth, a stage that was set, a story that may have begun and then stopped. Whether it ended before life began or after it had already taken root remains one of the greatest enigmas in planetary science. But we will keep searching. In every rock sample, every spectral scan, every rover's dusty tread, we are chasing the echoes of ancient life. Because if Mars ever lived, then the universe is no longer silent. It has spoken one ho and may do so again.